Some of you told me last week's episode felt a little too advanced, and that's exactly the kind of feedback I love, because it helps me make unhidden curriculum work for you. So today, no jargon, no judgment, we're going to cover the absolute basics everyone should know about using a computer. Like what even is an operating system, how do files and folders work, why do some files end in .txt or .csv, and what are those little tricks like copy and paste shortcuts that make life so much easier once you know them. And let me pause here and say this really clearly. You belong here. Even if you've never heard of a terminal window and you're not sure what a file extension is, you're in the right place. Here's the thing. Computers aren't just nice to have for scientists. They're the backbone of modern science and honestly most jobs these days. So these aren't basic skills, they're professional tools. And the earlier you feel comfortable with them, the stronger your foundation will be for everything else. I'm Megan Puglia, this is Unhidden Curriculum, and today we're going to slow it down, strip away the jargon, and start from the absolute basics of how to use a computer, whether you're doing science, managing data, or just trying to stay organized. So let's rewind. Okay, first things first. Your computer needs something called an operating system. Think of it like the manager of your computer. It tells all the programs and files exactly how to work together. Without it, your computer is just an expensive paperweight. There are three main operating systems you'll hear about. Windows is made by Microsoft. This is one of the most common ones used in offices and schools. It's very flexible and works on a lot of different computers. Mac or Mac OS is made by Apple. If you've got a MacBook or an iMac, this is what's running behind the scenes. It's known for looking clean and being user-friendly. And then Linux. This one's a bit different. It's open source, which means anyone can see the code and modify it. Scientists and programmers like Linux because it's highly customizable and powerful. But it can feel tricky at first and isn't as common in everyday life. Today, we'll focus on Windows and Mac, but we'll cover Linux basics in a future episode when we get to high-performance computing. Now, you don't need to know everything about each operating system. The key is understanding that they do the same basic job. They let you run programs, save files, and organize your work. When I show steps today, like creating a folder or opening a file, I'll show both Windows and Mac versions so you can follow along no matter what computer you have. Of course, to actually use your computer, you'll need your keyboard and mouse or trackpad. On your mouse, a left click is your basic action. Open, select, drag. A right click gives you a shortcut menu with extra options, like renaming a file or copying text. On a Mac, you can right-click by holding the Control key while clicking, or by setting up a secondary click in your trackpad or mouse settings. When you first log into your computer, what you see is called the desktop. It's your main workspace. You'll see little pictures called icons for files, folders, or programs you want quick access to. At the bottom of your screen, you'll find either the taskbar on Windows or the dock on Mac. This is your quick launch strip. It lets you pin your favorites so they're always one click away. To pin something, just right-click an Open Programs icon and choose the option to pin in Windows or keep in dock on Mac. On Windows, you'll also see the Start button on the far left of the taskbar. It's where you go to find all your apps, settings, and power options. On a Mac, the equivalent is Finder. Finder is where you can browse all your files, folders, and applications. Then there are menus, usually at the top of each window. Menus are like the control panels for your programs. They let you do things like open, save, print, or adjust settings. Together, the desktop, the taskbar or dock, and the menus make up the surface layer of your operating system. Now that we know about operating systems, let's talk about files and folders. Think of your computer like a filing cabinet. Folders, which are also called directories, are the drawers in your cabinet. They hold your files and can also hold other folders, which are called subfolders. Both Windows and Mac have built-in graphical interfaces that lets you see and interact with your folders and files visually. Graphical user interfaces, or GUIs, are tools that let you click on windows, icons, buttons, and menus instead of typing commands. File Explorer on Windows and Finder on Mac are examples. You can point and click to open files, move folders, or run programs. It's like looking inside your filing cabinet and opening drawers to see what's inside. To create a new folder on Windows, open File Explorer, go to the folder where you want the new folder, and then click the new folder icon, right-click and select New Folder, or use the shortcut Control-Shift-N. On a Mac, click the Perform Task button, or right-click or Control-click and select New Folder, or use the shortcut Shift-Command-N. You can also drag and drop files into folders by clicking and holding as you move them, just like sliding papers into a drawer. Now onto files. Files are like individual pieces of paper in those drawers. Each file has a path, a name, and a type. Let's start with the path. This is the location of the file on your computer, meaning which folder or folders hold it. Now, all computers have what's called a home directory. This is the main folder on your computer where all of your personal files live. On Windows, it's C:\user your name, and on a Mac, it's usually /users your name. Now, when we talk about the path or location of your file, we can refer to either the absolute path, which is the full address from the very top of your file system down to the file. So for example, users, Megan, my project, source data, subject 1, session 1, data file. Or the relative path, which is the address relative to where you currently are in the folder structure. So if I'm already in the source data folder, my relative path to the data file would be sub1 session 1 data file. Think of the absolute path like giving someone the full street address to your house versus just saying the living room, which would be the relative path if they're already inside your house. Want to find the absolute path of a file? On Windows, click the address bar at the top of File Explorer to see the full path to the folder and then add the file name. You can also hold Shift, right-click the file, and select Copy as Path. On Mac, right-click or command-click the file and choose Get Info. The path is located under Where. Or hold the Option key while right-clicking, then select Copy File as Path Name to copy the full path. Next up is file types. You may have noticed files have letters after a period, like .txt or .tsv. That's called a file extension, and it tells your computer what kind of file it is. For example, .txt is a plain text, whereas .csv is a spreadsheet with comma-separated values, CSV. This extension is like a label telling your computer and you how to open it. Finally, let's talk file names. Think of them as labels that tell you and anyone else what's inside the file without having to open it. A good file name saves time, avoids confusion, and keeps your digital workspace organized. Now here are some critical pro tips on naming files. First up, never put spaces in file names. Let me say that again. Never put spaces in file names. This is super important if you plan to do any programming or serious data work, which most science, technology, or engineering careers will require. Spaces can break scripts and make your life miserable. So what to do instead? Use underscores to separate words, or use camel case, where you capitalize the first letter of each word. Name files clearly. Instead of data final version 3, try something like experiment 1, participant data, and year, month, day. It's clear, readable, and easy to sort. And finally, use folders to separate types of files. Raw data, processed data, scripts, reports. This is the start of good scientific habits. Already have spaces or final in your file name? No worries, it's easy to rename. On both Windows and Mac, just click the file once, pause, and click the name again, or right-click and choose Rename. And one key tip, don't try to change a file's type by renaming the extension like this, like switching .txt to .csv. That won't actually convert the file. It's like calling a pizza a salad. Your computer will still treat it like a pizza, and it might not open correctly. Always use the program's Save As or Export options, which are usually under the File menu, to safely change file types. So why does all this matter? If you keep everything in one big pile on your desktop, chaos. With poorly organized folders, you'll spend hours searching for that one file you need. Poorly named files, you'll need to open each one to understand what's inside. Organizing now will save you tons of time later. Now that we've got files and folders under control, let's talk about the main types of files you'll be working with and look at common programs you'll use for each. Each has a purpose, and knowing the differences will save you a lot of headaches. First up, plain text files. These are just raw text, letters, numbers, and symbols. No bold, no colors, no fancy formatting. Think of them as a blank piece of paper. They're perfect for notes, lists, or code. Because they're so simple, almost any program can open them. For plain text, BB Edit on Mac or Notepad on Windows, and Text Edit on Mac if you set it to plain text mode, are simple text editors. They're like plain text files, but with a few extra tools to make coding or managing text easier. Scientists love plain text because it's simple, stable, and works across computers and software. No hidden formatting that can break things, like when writing code or keeping structured notes. Common extensions include .txt, .csv, or .tsv for tab-separated values, and code files like .py for Python scripts or .r for R scripts. Next, formatted text documents. These are what you use when you want bold, italics, images, tables, or page layouts. This is the type of file you'll use for writing papers, lab reports, or any document that needs to look nice. You'll use word processors such as Microsoft Word, Google Docs, or Pages on Mac. These programs also have features that are especially useful for science and collaboration, like track changes, which lets you see exactly who edited what, and comments, which allow you to leave notes for yourself or collaborators. They make writing, reviewing, and revising documents much easier, especially when multiple people are working on the same file. Markdown files with the .md extension are a mix between plain text and formatted text. They are still plain text, but you can add simple formatting using symbols like the pound or hashtag for headers or the asterisk for bullet points. If you want to get all fancy with the README file, which we talked about last time, Markdown is the most common choice because it's human readable and can be converted into clean-looking web pages. That said, any file type that works for your README is fine. Markdown just makes sharing and formatting easier. PDFs or portable document format types end in .pdf and are another common file type. They're designed to look the same on any device, so if you send a PDF to someone else, it won't change its appearance. Scientists love PDFs for things like articles, grant proposals, or forms. Basically anything where you don't want the formatting to shift or break. You can view them in your browser, Preview on Mac, or Adobe Acrobat Reader on either Windows or Mac. Some programs allow annotations or minor edits, making PDFs versatile for sharing, reviewing, and filling out forms. Binary files. Many programs use binary files, including Word, Excel, PDFs, images, and specialized neuroscience software. These files store complex information in a way computers understand, but if you try to open them in a plain text editor, you'll just see unintelligible nonsense. Spreadsheets are grids of rows and columns. They are essential for data organization, analysis, and calculations. They're also super flexible for sorting, filtering, and even making graphs. You can open .csv or .tsv files in a text editor, but spreadsheet programs like Microsoft Excel, Google Sheets, or Numbers on Mac make it much easier to read, sort, and filter your data. All right, one quick note on software choices before we move on to how to actually get these software tools onto your computer. Microsoft Office apps are paid and installed on your computer. They have lots of advanced features and are widely used in professional and academic settings. Google Docs and Sheets, on the other hand, are free and cloud-based, which means you can access them from any computer with an internet connection, and they make sharing and collaborating simple. The trade-off is there's slightly fewer advanced features compared with Microsoft products. Okay, now that you know about file types and programs, let's talk about software itself. Software is just a fancy word for programs or apps that run on your computer. Software is what lets your computer do things. Without it, your computer really can't do much. It's just a fancy screen and keyboard. Examples of software include Microsoft Word to write papers, Google Chrome to browse the web, Zoom to video chat, and Excel to work with spreadsheets. And speaking of browsing the web, that's where web browsers come in. A browser is a program that lets you visit websites, download files, and access online tools. Popular ones include Google Chrome, Safari on Mac, and Microsoft Edge on Windows. Browsers are essential. They let you get new software, open online tools like Google Docs or Sheets, and explore the web for anything you need. So how do you get new software? You install it. Installing just means downloading the program and putting it in the right spot so your computer knows how to use it. Usually there are two ways to do this. One is downloading from the internet. You go to the official website of the software and download the installer. Most browsers will save this to your Downloads folder, which you can access in File Explorer on Windows or Finder on Mac. To install the software on Windows, double-click the .exe or .msi installer file and follow the instructions, which usually just involves clicking Next a few times. Then the program is installed. On a Mac, double-click on the .dmg file, then drag the application into your Applications folder. Sometimes the installer will guide you through a few extra steps. The other way is through an app store. Both Windows and Mac have built-in app stores, like the Microsoft Store or the Mac App Store, where you can safely download programs. A quick word on safety. Always download software from a trusted source. Random websites might include malware, which are files that can harm your computer or steal your information. Official websites or app stores are the safest option. Once installed, most programs appear in your Applications folder on a Mac or the Start menu on Windows. You can drag them to your desktop or taskbar for quick access. And now you're ready to open your software and start using it for whatever task comes next: writing, data analysis, or even just browsing the web. All right, now that we've covered the basics, let's talk about some simple tips to make your computing life way easier and maybe even a little fun. Think of this as your Compute Like a Pro toolkit. First up, keyboard shortcuts. These little combos save tons of time and clicks. First up, here are some general shortcuts that I use all the time to copy, paste, undo, redo, search and find, insert hyperlinks, save, print, and select all. Next, these handy shortcuts will make navigating your computer so much easier, like showing or hiding the desktop, switching between open apps, switching between windows of an app, switching between tabs, and connecting to servers or network drives. And finally, these shortcuts will help with navigating text, which will become particularly useful when we begin working in the terminal window to jump through text word by word, jump to the beginning of a line, or jump to the end of a line. And if you ever forget a shortcut or want to discover new ones, most programs list the keyboard equivalent right next to the menu option you'd normally click. Even just remembering a few of these can make navigating your computer way less frustrating. Next, let's talk about permissions, which determines who can do what on your computer. On your personal laptop or computer, you're usually the administrator, which means you can install software, create folders, and manage access. On shared computers like your school or work computer, your IT department will use permissions to protect sensitive files. You might be able to read a file but not edit or delete it. Knowing this saves headaches later. On Windows, you can see and change permissions by right-clicking a file, selecting Properties, and looking under the Security tab. On a Mac, right-click or control-click a file, choose Get Info, and scroll to Sharing and Permissions. If you have admin access, you can click the lock icon and adjust who can read or change the file. Backing up your files is next. Never underestimate it. You have a few options: your local hard drive, which is your own computer, an external drive, which you can plug into your computer, or cloud storage like Google Drive or OneDrive. The rule of thumb is to keep at least 2 copies of anything important, like your raw data. Trust me, future you will thank you. Next, let's talk about archives and compression. Sometimes you'll want to bundle multiple files together or make them smaller. That's where zip files come in. Think of them like a neat little package that's easy to send or store. To create a zip file on Windows, right-click the file or folder, then choose Send to Compressed Zipped Folder. On a Mac, right-click or control-click the file or folder and select Compress. To open a zip, just double-click it on a Mac, or on a Windows, double-click and drag the contents to where you want them, or right-click and choose Extract All. Finally, let's talk about switching between file types. Remember, you can't just rename the extension. Changing .txt to .csv won't convert the file. Always use the program's Save As or Export options under the File menu to change formats. And here's why plain text editors come in handy. They let you see what's really inside the file, which is often critical for programming. For example, in a spreadsheet, Excel might hide commas, tabs, or other special characters that separate your data into columns and rows. Opening the same file in BBEdit or Notepad shows these characters explicitly, which helps you spot issues before they cause errors in code or data analysis. This is why scientists and programmers often prefer plain text for code and structured data. It behaves predictably across programs and computers. So much of what we do, science and otherwise, is powered by computers. As a scientist, you'll write papers, analyze data, run simulations, and collaborate with others, all on a computer. If you don't have the basics down, everything else becomes harder. But once you do, you'll be ready to level up to programming, data analysis, and more advanced research workflows. This episode was inspired by your feedback, so thank you for helping me make these lessons more useful. If you have thoughts or questions, drop a comment. Let me know what's working, what's confusing, or what you want me to cover next. Everyone belongs here, even if you're starting from zero. Next time, we'll build on this episode with an introduction to key concepts in programming. Learning to code will let you take control of your computer and research in ways that are just not possible with clicks and menus alone. If you found this episode helpful, consider sharing it with a classmate or even your grandma who's just called for the 15th time asking how to export to PDF. And think of subscribing like creating a shortcut for yourself. It saves you time, keeps you on track, and makes sure you don't lose sight of what's important. Until next time, explore your apps, master your shortcuts, and of course, stay curious.